Lesson 65 is on distinguishing types of parallelograms. Okay, so this is kind of a lesson to bring lots of concepts together. So we've talked about parallelograms and different kinds of quadrilaterals. We have definitions of those quadrilaterals. We have properties of the quadrilaterals. And sometimes it's hard to keep track of all of those things. So I think this is a good time for us to kind of put them all down in one place so that we can see everything. So first of all, let's look at definitions. Okay, so we're going to look at definitions. So definitions, some things that we have defined are, we'll just go with the family of specific types of quadrilaterals. I'm not going to bother defining quadrilateral here. I'll just assume you know what a quadrilateral is. It's a polygon with 4 sides. But a parallelogram, okay, in terms of the definition, think about the word like it's got parallel in there. Okay, so the definition is going to do with the fact that there's something about parallel things in there, right? So a parallelogram is a quadrilateral with 2 pairs of parallel opposite sides. Okay. Now there's lots of properties that we know about parallelograms, like things like those opposite sides are also congruent, but that's not part of the definition. The definition is just that the opposite sides are parallel. Okay, and then we have a rectangle. The definition of a rectangle is just a quadrilateral with 4 right angles. Okay, so it happens to have properties. We know some, but that's not part of the definition. Just the right angles are the only part of the definition. A rhombus, okay, is a quadrilateral with 4 congruent sides. Okay, that's all we know. Yes, again, we know some other properties, but that's not part of the definition. It's just got 4 congruent sides. And then a square is a regular quadrilateral. And what does it mean to be regular? Well, regular means that all of its sides are congruent, so it's got 4 congruent sides. And it's got 4 congruent angles. Okay, and 4 congruent angles means there are all 90 degrees. Okay, so 4 congruent right angles. So those would be the definitions for each of those. Okay, and then we have various properties. So in lesson 34, we learned some properties of parallelograms. Okay, and so all of these look like, if I know it's a parallelogram, then this must be true. If I know it's a parallelogram, then this must be true. If I know it's a parallelogram, then this must be true. Okay, so these are properties, I already know it's a parallelogram, and because it's a parallelogram, I can conclude these other things. So we have, if it's a parallelogram, okay, then what do we know it's true? Well, we know that its opposite sides are congruent. Okay, if it's a parallelogram, what else do we know? Well, then we know that its opposite angles are congruent. If it's a parallelogram, then we know that the consecutive angles are supplementary. And there's one more. If it's a parallelogram, then we know that the diagonals bisect each other. We just did this recently, so this should be ringing a bell. Okay, so those are the properties of parallelograms. We know it's a parallelogram, then these things are true. Okay, then that was sort of early on. That was lesson 34. So we're talking about beginning of, or like end of first quarter, beginning of second quarter. I can't remember when we did that. Okay, then later on in lesson 52, we talked about properties, not just of general parallelograms, but of specific ones, rectangles, rhombuses, and squares. So we did that next. So properties of rectangles, rhombuses, squares. Again, so these properties, oops, are going to be, if I know it's one of these, then what can I conclude? So in particular, we'll look at rectangles first. So if I know it's a rectangle, there's something very unique to rectangles. If it's a rectangle, then the diagonals are congruent. This is unique to rectangles. It's not true in general parallelograms. It's not true in just general rhombuses. Okay, so it's only true for things that are can be classified as rectangles. Okay, that's the only one for rectangles. And then rhombuses. So if I know it's a rhombus, okay, the diagonals aren't congruent, but in a rhombus, the diagonals are perpendicular. Okay. And one other thing about rhombuses, if it's a rhombus, then I know that the diagonals bisect the angles. Now, we don't list specific things for squares because we know that all squares are both rhombuses and rectangles. So squares, because they're rectangles, are going to have diagonals that are congruent. Squares, because they're rhombuses, are going to have diagonals that are perpendicular. Squares, because they're rhombuses, are going to have diagonals that bisect the angles that they go through. So we don't list specific things for squares because squares automatically get everything that rectangles and rhombuses get because they can be classified as both of those. So we're not going to write down all of those, but squares would be all of these things. Okay. And then after we did properties of parallelograms and rectangles and rhombuses and squares, then we wanted to look at, okay, how can you determine if something is a parallelogram? So that's what we looked at in lesson 61. So this is when we looked at determining if quadrilateral is a parallelogram. Okay. So it's unlike these. I don't already know it's a parallelogram. It's not if parallelogram, then conclude something. These ones are going to be if these things are true, then it's a parallelogram. So parallelogram is going to be the conclusion, not the hypothesis. And a lot of these are basically converses of these other ones. So we know, all right, if the opposite, so if we have two pairs of opposite sides that are congruent, well, then we're going to get that it's a parallelogram. Okay, so it's the converse of this one. If we have two pairs of opposite angles, that are congruent, then we'll know it's a parallelogram. That's the converse of this one. Okay. We don't have the converse of this one. We do have the converse of this one. If the diagonals bisect each other. And it's a parallelogram. Okay. And our last one was if we have one pair of congruent parallel opposite sides, then it's a parallelogram. Okay, and so this kind of goes with the partial part of the definition. Okay, so we have to, from the parallel sides. Now this one definition has two pairs. We only have to have one pair here. Okay, so that one pair of parallel sides, to ensure that it's a parallelogram, we also have to have this property down here of that one pair of parallel sides would have to be congruent. So it's kind of like a mixture of the definition and this property of parallelograms. Okay, but those would be, notice like the difference between these two. Here we know it's a parallelogram, we conclude something. These are sort of like converses. We know something and then we conclude it's a parallelogram. And so the obvious thing that we're missing in all of this is we need something similar for, if I have this property, then I know it's a rectangle, or then I know it's a rhombus. And that's what we want to do today in lesson 65, distinguishing the type of parallelogram. Is it a rectangle? Is it a rhombus? Okay, and then as you can imagine, just like most of these look like converses of the properties that we had over here, these are going to be like the converses of the properties over here. Okay, so now we're looking at distinguishing types of parallelograms. Okay, here. And so first we have, and all of these are, we have to know it's a parallelogram. So if it's a parallelogram and we have a right angle, okay, so let's think about this. Okay, we know it's a parallelogram and we know that there's a right angle in it. Well, where have we seen right angles? Oh, right angles, that's something that appears in a rectangle. So sure enough, if we know that, then we know that it's going to be a rectangle. Okay, so that's one way that we can know that something is a rectangle. All right, we have another one. If it's a parallelogram, and all of these we have to have parallelograms. Okay, and let's say the diagonals were congruent. Then what could it be? Well, where have we seen diagonals congruent? Okay, so diagonals congruent. Okay, that's where this one showed up. If the diagonals are congruent, it's definitely going to be a rectangle. Okay, so it's essentially the converse of this one right here. Okay, so this one is a rectangle. So this one goes back to the definition. This one is the converse of this property. Okay, so those are our rectangle ones. And then we have some other ones. So if we know it's a parallelogram, and the consecutive sides are congruent. Now this is a little bit of a tricky one. Okay, so you might be tempted to say, oh, well, okay, where have we seen sides being congruent before? Oh, opposite sides congruent, opposite side. All of this just gave us that it's a parallelogram. Okay, I already know it's a parallelogram. But this one is saying that the consecutive sides, not the opposite sides, but the consecutive sides. Okay, so those are the ones that, share, that they intersect each other. So what could that be? Okay, if we go back here, well, that would mean that not just the opposite sides, but the ones that are next to each other as well. Okay, we already get the opposite sides from parallel, but also the ones that are beside each other. So that means all of the sides are congruent. It must be a rhombus. So this one is for rhombus. Okay, if it's a parallelogram, and the diagonals are perpendicular. Okay, well, where have we seen that before? Oh, diagonals are perpendicular. We've seen that over here. Okay, that only happens in a rhombus. This is a rhombus. Okay, and finally, if it's a parallelogram, and I know that the diagonals bisect the angles. Okay, and again, where have I seen that before? Okay, this one's going to be a rhombus. Okay, so again, we're seeing a lot of things that are basically converses. These are converses, these are converses, these are converses. Now this one goes back to a definition, and this one goes back to a definition. Okay. But, sorry. Hopefully you can see all that now. Alright, so, but that kind of puts everything together in one place. So if you're trying to prove that something is a parallelogram, you want to be using this stuff. If you're wanting to prove that something is a rectangle, or wanting to prove something is a rhombus, okay, you should be using this stuff. If you are trying to prove something about, you know, congruent sides or congruent diagonals, like, you know, this is the stuff over here. You'd be using these ones. So if you look at the hypotheses and conclusions of all of these, this can help you just determine when you should use these. All right. So let's look at some problems from the book and how we would use these. All right. So in our first problem, problem A, they're asking us, is this parallelogram a rectangle? So we know that it's a parallelogram. We don't know if it's a rectangle. It's a parallelogram, so it's got two pairs of parallel sides. What would we have to do to show that it's a rectangle? Okay, well, we could... Okay, so to conclude that it's a rectangle, we could either show that it has a right angle, or we could show that the diagonals are congruent to each other. All right, well, what is more likely for us to be able to do? Well, they've given us information about some angles. They've given us nothing about diagonals at all. So probably we're going to try to figure out if we've got any right angles in here. Okay, well, because it's a parallelogram, I know that it has all the properties of a parallelogram. These are opposite angles. What's true about the opposite angles of a parallelogram? Well, they're congruent. And so I would start out this problem by writing the equation 6x plus 12, which is the measure of one angle, is equal to 7x minus 1, because that is the measure of the opposite angle. And I just need to solve that. So I'll subtract 6x from both sides. I'll add 1 to both sides. I'll get 13 equals x. Okay, well, if x is 13, then let me just look at one of those angles. It doesn't matter which one. I'll just do the top one. And I know the top angle is 6x, or 6 times 13 plus 12. 6 times 13 is 78, plus 12 is 90. So I know that I have a 90-degree angle. As long as a parallelogram has one right angle, okay, this is a right angle, so it's indeed a rectangle. Okay, let's look at B. Okay, in B, we've got this diagram, and they're asking us, is this a rhombus? We know it's a parallelogram. Is it a rhombus? So let's go check our properties here. So how could I conclude that it's a rhombus? Well, there's three different ways to conclude that something's a rhombus, right? I could see that the parallelogram has consecutive sides that are congruent, that it's got diagonals that are perpendicular, or it's got diagonals that bisect the angles. Okay, so looking at the information that they gave us, okay, nothing about diagonals at all. So probably we're going to have to look and see if consecutive sides are congruent. Now we can't just set two sides equal to, we don't know, we have to figure out. So we know it's a parallelogram, we don't know if it's a rhombus. Okay, so we have to go from properties of a parallelogram. Well, what's true about a parallelogram? Well, in a parallelogram, the opposite sides are congruent. And I have lengths of opposite sides. 4x plus 7, I know has to be the same thing as 9x minus 5 because these are opposite sides of a parallelogram, and I know it's a parallelogram. So I'm going to start by writing the equation 4x plus 7 equals 9x minus 5. And then I can solve those. All right, I'm going to subtract 4x from both sides, and I'm going to add 5 to both sides. So I'll get 12 equals 5x, which means that x is 12/5. Okay, so now I can look for one of those side lengths. I'll just look at the top one. I know the top side has a length 4 times x, which is 12/5 plus 7. So we've got 48/5 plus 7. I want to have the common denominator though, so that is 35/5. So 48/5 and 35/5 is going to be 83/5. Now I'll compare that, going back to my picture, I now know that this is 83/5. Well, this is 81/5. These consecutive sides do not have the same length. Okay, I don't have consecutive sides that are congruent, so it's not a rhombus. This 83/5 is not equal to 81/5, so it's not a rhombus. Okay, let's look at C. Okay. So we're looking at this one. We want to know if this parallelogram is a rectangle. Remember, there's two ways for rectangles. We can see if we have a right angle. We can see if the diagonals are congruent to each other. Well, they've given us some lengths of segments here. They've given us nothing about angles. We're probably going to go for diagonals or congruent, right? Now, we can't just assume they're congruent. We have to prove they're congruent. All we know is properties of a parallelogram. It's a parallelogram. What's true about parallelograms? Well, what's true is that the diagonals bisect each other. And I can see that AC is clearly bisected. But we also know that BD is bisected. And since it's bisected, this DO length of x minus 3 is equal to this OB length of 1/2 x plus 1. Okay, so we'll start this by writing the equation x minus 3 equals 1/2 x plus 1 because I know that diagonal is bisected because it's a parallelogram. All right, let's start by clearing fractions. Let's multiply both sides by 2. So I'll get 2x minus 6 equals x plus 2. Then let's subtract x from both sides, add 6 to both sides, and I'll get x equals 8. Okay, now I can plug in that 8 and get that DO is 8 minus 3, which is 5. And we can get that OB is 1/2 of x, or 1/2 of 8 plus 1. 4 plus 1 is 5. Okay, and so if I take DO plus OB, that is 10, which means by the segment addition postulate that DB is 10. DB is 10. AC is also 10. Okay, since those are two diagonals with the same length, they're congruent to each other. The diagonals are congruent, so it's a rectangle. Let's look at D. We're trying to figure out if this is a rhombus. Remember, there's 3 ways to get rhombuses. We can get consecutive sides that are congruent. We can get diagonals that are perpendicular, or diagonals that bisect angles. Okay, so they've given us absolutely nothing about side lengths. What they've only given us is some angles here. Okay. They haven't given us anything about angles up here, so probably not. We're not going to go for bisecting, We're not going to go for consecutive sides. Let's see if the diagonals are perpendicular to each other. Now, we cannot just start this problem by setting these things equal to each other. We don't know if they're equal to each other. That's what we're trying to figure out. If they are, then it's a rhombus. If they're not, it's not a rhombus, but I can't just assume it's a rhombus. Okay, all I know is it's a parallelogram. I have to start only using information that I actually know is true. I don't know if these two things are equal to each other, but I do know that this is a straight line, and so that these two angles are a linear pair. I know that they're supplementary to each other. So the equation that I have to start out with here is 4x plus 13 plus 6x minus 13 equals 180. Okay, they're a linear pair, they're supplementary. When you add them up, you're going to get 180. Okay, so 13 minus 13 is 0. Those go away, so I'll end up with 10x equals 180. Dividing both sides by 10, I'll get x equals 18. So if x equals 18, then that one angle is 4 times x, which is 18, plus 13. That's 72 plus 13. This is 85 degrees. Okay, so what this is telling me is that this angle right here is 85 degrees. It's not a right angle. If it's not a right angle, these aren't perpendicular to each other. Okay, so this is not a right angle. So the diagonals aren't perpendicular, and it's not a rhombus. Okay. Going on to E. Okay, you want to see if this one is a rhombus. Okay, probably you, when you look at this, you see we've got this diagonal, and they're telling us some stuff about the measures of the angles here. So probably we're going to go and try to see if the diagonal bisects these angles. It's got to be. Okay, so do we have angles that are bisected up here? So we know it's a parallelogram. Because it's a parallelogram, we have two pairs of parallel opposite sides. This side and this side are parallel to each other. And so if I have parallel sides, this diagonal can be treated as a transversal. Now we know all sorts of things about what happens when we have parallel sides in a transversal. And one of them is that the alternate interior angles are congruent. And so this angle right here with measure 2x plus 11 and this angle here with measure 4x minus 3 have to be congruent because I know it's a parallelogram. Okay, so only based on information about it being a parallelogram. So I'm going to start out with an equation that 2x plus 11 is equal to the measure of the alternate interior angle, which is 4x minus 3. I'll subtract 2x from both sides, add 3 to both sides. I'll get 14 equals 2x, which means x has to be 7. Okay, well if x is 7, on the top we have 2x, or 2 times 7 plus 11. That's 14, and 11 is 25. Then we have 3x plus 4, or 3 times 7 plus 4. That's 21 plus 4. That's 25. So that angle on the top is bisected. The angle on the bottom, we have 5x, or 5 times 7 minus 10. That's 35 minus 10 is 25. And then 4x, or 4 times 7 minus 3. That's 28 minus 3, which is 25. Okay, so, you know, both angles are bisected by the diagonal. So it's a rhombus. And finally, let's look at F. Okay, so in F, we've got a parallelogram, And we know that the diagonals create this equilateral triangle here. So this side, and this side, and the triangle are congruent. And we want to know, is the sign actually a rectangle? So we've got something like this. We've got these diagonals. This is an equilateral triangle, and we want to know, is it actually a rectangle? So there's two ways to prove a rectangle. We can either try to look for a right angle, or we can see if the diagonals are congruent. Now we know something about at least little part of this diagonal and part of this diagonal, so it looks like probably going for the diagonals is the best approach on this one. So we have to argue from a standpoint of, I know it's a parallelogram. That's the only thing I knew. What's true about parallelograms, in particular thinking about the diagonals? They bisect each other. So that means this diagonal is cut in half. So this side and that side are the same. This diagonal is bisected, so this half and this half are the same. Okay. So let me just name these. This is A, B, C, D. Let's call this E. Okay, so if I take BE plus ED, I'm going to get exactly the same as AE plus EC because all of those are congruent to each other. So in the end, I'm going to get that BD is equal to AC, or that the diagonals are congruent. So the diagonals are congruent, so it's a rectangle. All right. So hopefully those are some good examples of how you can use the various properties. This is a good, this. Hopefully you wrote all these down, have them in one spot. So this is a nice, good summary. If I need to, prove that stuff's a rectangle or a rhombus, I'm looking here. If I need to prove something's a parallelogram, I'm looking here. If I need to prove, if I already know that it's a parallelogram or a rectangle or a rhombus, what kinds of things can I know about that? All those are over here, right? So kind of know what the hypothesis, what the conclusions are, and that'll help you solve the problems correctly.